All right. From physics, how do I calculate average velocity? Perfect. That's it. That's all it is. So average velocity, I'm just going to put average and then put the V there, is equal to displacement divided by the change in time. So how do I say displacement with calculus? Integral from A to B of V of t, that is displacement, divided by B minus A. We're going to rewrite it because it looks prettier this way. And don't worry, I'll zoom in. 1 over B minus A integral V of t dt, A to B. This is what we want. Does that make sense to you?
Yes.
Yeah. Okay. Now that we know that, this is average velocity, and I want you to observe. Let's just observe the formula. Average velocity, 1 over B minus A, integral A to B of V of t. Interesting. Okay. Using context clues, or using what we just learned just right now that you guys derived from scratch, what do you think I have to do to find average of F? Yeah, perfect. F of t or F of x, it doesn't matter. There it is. And you derived, in case you're wondering, like, why is that average? Well, how do we find average velocity? If this is average velocity, then average of anything will always be this formula. Does that make sense to you guys? Yeah, there it is. We got it, guys. Well, hopefully you understand what this means. I guess let's talk about what it means. So if I have something like, hopefully you can tell immediately. Let me see. Let me draw something. 0 and 10, 10. What's the average value of this function? It's okay. Yeah. No, just from basic instincts. This is my y-axis. This value is 0. This value is 10. This value, the origin is 0. This value is 10. From basic instincts, human nature, what is it? How do you feel if I tell you what's the average value of this function? We'll call it f. What do you feel it should be? What do you think? Not 50. You're close. Because it has to be, average value has to be between 0 and 10, right? 5. So the middle value is 5, and you can tell it's a nice linear line. Up here was 10, down here, well, the x value is 10, the slope is 1, negative 1. The average value is 5. So that means, what does that mean? If I were to find the area of this curve, and I were to make a rectangle, all that area would fit under 5. And that, you probably got 50 from 5 times 10, or 10 times 10 divided by 2. And it makes sense. So check it out. Look at this formula. Doesn't this mean area under the curve? Well, area under this curve, let's see, 10 times 10 is 100 divided by 2 is 50. And then look, B minus A divided by the difference. So 50 divided by 10, do I get 5? Yeah, I get 5. So there it is. Perfect. So hopefully now you have the idea of what it means to have an average value.
So the value is not the area of the curve. The value is...
It's just the average value. So that means it's not like this linear line, that's a 10 up here. I'm at 0. So what is the middle of all these numbers? Because I am descending at a constant rate, which is negative 1. The average value or the middle number would be 5.
So you're looking for
the average
sort of output?
the average of f.
The average
Yeah.
like y value?
Yeah, you can call it that. Like the average velocity. That's I don't want you to think of it like, oh, what's the average output? Because what if it's not? Like, what if I have an output that's always 10, between 0 and 10, and between 10 and 20, the output's always 20. So I never hit 15, but that's the average value.
Okay.
You know what I mean?
Yeah, okay.
So it's just an average, guys. It just means average. Just think about it like your velocity deal. Average velocity, displacement divided by time. Boom. That's not instantaneous velocity, that's just average. So this is just average of some function f. Now, just because it's average doesn't mean like I was just telling Taylor right now, like what if I have a function that looks like this? Party all the time. So I have 10 between 0 and 10. And then after I pass 10, I'm at 20 between 0 and 20. So notice that the average value between, it looks like it's 15. And it is. But notice that I'm never 15. At 10, I changed immediately from 10 to 20. Plus, this is not really a function, a vertical line test or whatever. But does that make sense to you guys? Okay.
One quick question. If you were solving using the average at like the formula, how do you, can you go through that?
Well, if I'm, we just did an example with this guy.
Yeah, can you do it without stuff?
Are you talking like for the next question or something?
Oh, never mind. I just can't multiply.
Okay. Here we go, guys. You guys ready? So we got the concept down, I think. So we're going to find out. Find the average value of the function x cubed between -2 and 2 and determine the number c on this interval for which f of c is equal to the average value. Did I write that correctly? Find the average value of the function x cubed on the interval -2 to 2 and determine the number c on this interval that sounds funny to me. For which f of c is equal to the average value. Okay, before we even start, what do you think the average value is of x cubed between -2 and 2? Do it visually. Yeah. Remember that x cubed is an odd function. So if I were to sketch this, it looks like, and I'm going to exaggerate the sketching. I'm exaggerating it. Here's -2. So I'm finding all this area. Here is 2. And I'm finding all this area. And what do we notice about those areas? They cancel each other out because they're the same magnitude. One's negative, one's positive. So the average value is 0. So if I'm answering this question, because this is a two-part question, and determine f of c where u equal the average value, well, where does this function equal 0? At 0. So f of 0 equals 0. So c is 0. But that's not a very interesting question. It comes out on UH. So that's probably why it's there. I want to see if it's true. I want to see if the average value really is 0. So I'm going to go integral -2 to 2 of x cubed. This looks easy enough. Of course, I still have 1 over 2 minus a -2, so that's a 1/4 in the front. So let's see. I guess here's my 1/4 in the front. Antiderivative of x cubed is x to the 4th over 4. I'm evaluating that from -2 to 2. Here's my 1/4. That's this 1/4. And then I put a giant bracket. And I'm going to put 2 to the 4th over 4 minus, parenthesis, -2 to the 4th over 4th. Let's see. Do I get a 0 in there? Did I do that right? I don't know. Wouldn't the what?
When you do upper minus lower, why did you just have one? When you go
Yeah, but I can factor it out because if there's a 1/4 here and a 1/4 here, I can just take it out. I think I did it right. Yeah, so I do in fact get 2 to the 4th. What's that? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, divided by 4. 4 minus, and then this turns to, again, another 4. And look at that, 4 minus 4, isn't that 0? So I did it right, guys, we did it right. With our math here, we got area under the average value is 0. And maybe this is not an interesting question. Maybe I should take it out, I don't know. What's up?
Okay, so I know like how we did all the math, but like at the beginning, how did you know it was?
Oh, because it's an odd function, and odd functions follow that they're symmetric about the origin. So this area here in blue is the same magnitude as this area in red. The only difference is it's below the x-axis, so it's negative. So negative area, positive area, same magnitude, cancel each other out. Because x cubed is odd. Not odder than weird, but odder than odd. Okay. How do we feel, guys? All right, let's continue. All right, average temperature. I've seen this done. I remember one year, I don't remember what class it was. Maybe it was an Algebra 2 class, or I don't know, maybe it was a statistics class. I can't remember, but I remember observing a teacher, and they were talking about temperature. Maybe it was a biology teacher. I can't remember. I don't think it was math. I think it was maybe science. And they were computing average temperature, and I really had to hold my breath because they were adding it and dividing by how many temperatures they got. That is not how you calculate average temperature. That's how you calculate your average grade. Oh, I got 5 grades, add them up, divided by 5. You cannot add up temperatures at random times and divide by how many temperatures you have. That is not average temperature, guys. Why?
Because it's not all at the same time.
Because temperature starts with the letter C. Temperature is continuous, so you can't just take abstract little random digits of temperature and be like, oh, add them up, divide by that number. That's the average temperature. Nope, you cannot do that. Do we understand? Okay, it might be close. It might be close if someone wants to try it out, but you cannot do that. So it says here, in Missouri measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So here it is. Here's noon. Here's midnight. Use Trapezoid to help you out. What is the average temperature for the 12-hour period? Because each height here, well, height for trapezoids is a 1, I can use my little formula. You don't have to. You can just find each trapezoid one at a time. Do you guys remember your formula? So I'm going to go 1 over 2, parenthesis. What's the first number I put? 63. What's the second number I put? Perfect. You guys remember 2 times 65 plus 2 times 66 plus ... means continuate plus, and usually want to show the last two. 2 times 58 plus 55. On the AP exam, guys, do not put ... They're not going to show you 12. I think they're going to show you like 6 or 7. Show them all of them. You know what I mean? Are we okay? Did I get anyone lost?
Why did they use 2 again?
Oh, because if we would have figured out the area of a trapezoid individually, we would have had to have done this. 63 plus 65 times 1 divided by 2 plus 65 plus 66 times 1 divided by 2 plus 66 plus 68 times 1 divided by 2 plus ... Notice that these 65s come out twice. Notice that these 66 come out twice, but this 63 only comes out once. So we're using the formula. I think the formula is h over 2, and then y naught plus 2y1 plus 2y2 plus ... 2y n's minus 1 plus y's of n. Any other questions, guys? Are we solid? Okay, take your calculators. Tell me what that average temperature is, please. And go slow. Don't, it's not a race. It's a marathon. You want to get used to your calculator, guys. So any chance you get, use it. Matter of fact, put it in your pocket. Have it out during lunchtime. You never know. Or do you guys have pockets?
No.
Okay. Just have it in your hand like a cell phone. Matter of fact, use your calculator more than your cell phone. I was actually going to forward you guys a really awesome video, but then I thought, like, man, they'll probably think it's lame, where someone rendered like a ray tracing program, and ray tracing programs are so hard to do, where there's like a sphere that is like, it mimics like light hitting the sphere and shadows, and they did it on a TI-84CE. Yeah, would you guys like to see that? Okay, I'll send it to you guys. I think it's super awesome.
We went to Rice, we were walking past the mathematics like building,
and we were walking past and there was a class going on. I don't know what it's called, but I looked inside and they were doing sinusoids.
Yeah.
Oh yeah. I was like,
You know sinusoids.
and they were like, and there's another one in another building, and they were talking about. I saw on the board second derivatives, and I like saw the D. Yeah. And it was,
Yeah. Yeah, we're not pretending to do calculus. We're doing real calculus.
I feel like I did this wrong.
What'd you get?
I got this, yeah. I got 780. That's not a rational number. Like that doesn't make sense. I got something in the 700. Yeah, I got 782.
Oh, that's because you haven't done something. That's just the this, you just found the area under the curve. So you just did this, right? This is just area under the curve. What do you got? You haven't done 1 over b minus a. So it's okay. Give me that big number that you got.
782.
782 point. Oh, okay, 782. So now you're gonna go 1 over. What's the difference between noon and midnight? Is it 12? Oh yeah, it is. I was gonna say 24. 1/12 times 782. So what you did. So let me put what you did. You did this. You went from 0 to 12 of temperature. That's what that 782 is. Now what do you get? What is, no. Yeah. 65 point. Perfect. All right. So how do you know this is correct? Okay, guys, look. The coldest temperature I see in here is 55, and the hottest temperature I see is 70. It better be a number between 55 and 70. If you get a number like 80, do you ever hit 80? If you get a number like 30, do you ever hit 30? That's how you can tell. And 65, if you look, let's see, 63, 65, 68, 70, 69, 68. Yeah, 65 sounds about right. It sounds like it would be in the middle, the average. Now, don't get it confused for median. That's totally different, but that's the average temperature. So this is how meteorologists, of course, they just have a computer tell them that. But this is how that algorithm, this is the algorithm for what the computer does to find the average temperature. Isn't that cool? I think it's cool. Okay. In 2016, good thing I'm not giving this one, 44% of test takers got this question correct. And I don't know why I put will you, like if this is a like a game host or something. All right, do you want to take 2 minutes? This is with no calculator. Do you want to take 2 minutes and see if you guys can get it right? And it's okay if you get it wrong, guys. We're just learning this. If you're still working on it, keep working on it. I'm just going to start with the first steps. If you did that, you're winning. Did you at least do that?
Yes.
Perfect. You cannot take the, well, I guess you can, but one of the steps you guys like to do is you guys like to write this. Do not do it for this one, because if you add 1 to that exponent, you get 0, and then you divide by that 0. You can't do that. But hopefully the answers gave you big hints. Look at these answers there. What do you see? What is the antiderivative of 1 over x? ln. So here's what you're going to have. 6 minus 4, what's that? 2. So 1/2, then bracket ln x, close it, 4 to 6. You can keep the half factored out, or you can put it with the ln. It doesn't matter in the end. I'm going to keep it factored out. This half is this half. Are we still okay?
Yes.
All right, so here we go. 1/2. I continue with my bracket to indicate that I'm evaluating the ln. I'm going to do upper minus lower. ln of 6 minus ln of 4. Are we still okay? Now, if you remember your properties, this is the same thing as saying ln of 6 over 4, and then 6, 4 reduces 2. So 1/2 ln of 3 over 2. Now they have that answer in there. The answer is C. But if they didn't have C, is there another way they could have written it? Yes, they could have written it as ln square root of 3 over 2. Because that half means ln 3/2 to the power half. Are we cool? So make sure you know about your properties, guys. Because as you can see, calculus is easy. It's the algebra that makes it hard. Are we cool? All right, so there we go. The answer is C. Who got it right? Good job. You're already, and look, we just started. These are people who have been taking calculus the whole school year, and only 44% got it right. What's up, Parker? Oh, sorry. I thought I saw a delay there. All right, let's go to the next question. Oh, we can't do that one yet. Okay, we can, but it's called use sub. Well, I guess let's talk about it first. It says, what is the average value f of x equals sin x cosine x on the closed interval 0 to pi? And you're correct. If you can do this, average of f equals 1 over pi minus 2 minus 0 integral 0 to pi over 2 sine x cosine x dx. This is correct. You guys just need more algebraic skills. We haven't done, it's called U sub. Do you guys want me to do it now, or should we save it for later? Save it for later? Okay, remember when we do U sub to come back to this. So remind me, guys, because I'll forget. Are you guys going to remind me? All right, make sure to remind me. All right, this one we can do. Let's do it together. Suppose that b is greater than 0 and the average value of f of x equals 5x minus 3 on 0 to b is 1/4. Find the value of b. Really? This is more like an algebra problem more than anything. The only calculus is the setup. So what is the setup? Here's the setup. I want the average, and they already tell me the average, don't they not? And the average value, yeah. Average of f. What's the average? 1/4. So here it is. I'm going to write a statement. So the statement is the only calculus part. 1 over b minus 0 integral from 0 to b of 5x minus 3 closed dx equals 1/4. Well, I guess doing the antiderivative is also part of the calculus, but it's not much calculus. Are we still okay, guys? All right. I'm not taking a derivative or anything, so don't be like, oh, there's a variable on the top and a constant on the bottom. Oh, it must be 5x minus 3. No, there's no, do you see d dx anywhere? No, we're not taking a derivative. The first thing I want to do, I'm going to get rid of that minus 0, and I'm just going to write it as 1 minus b. Did I confuse anyone there? All right, the first thing I want to do is I want to get rid of that b there, 1 over b. So I do that by, multiplying. So multiply. So I'm going to go times b. So here's what I now have. I have integral 0 to b, 5x minus 3 dx equals b over 4. Are we still okay? All right, now I'm going to do antiderivative. So this is the only calculus that you have in this one. Well, the setup and this. I'm going to do antiderivative of that, and I'm going to put upper minus lower. That b is a number, guys. We don't know what that number is. So here we go. Antiderivative of 5x is 5x squared over 2 minus antiderivative of 3x. And it's these two terms that I'm going to evaluate from 0 to b. And all that still equals what? B over 4. So get it up to there. You're done with calculus. Everything else is algebra. Do I got to worry about that 0? No, because it's going to 0 out. If I had exponentials, then it doesn't. But I have a polynomial, it's going to 0 out. So all you're going to have is what letter? B's. So here we go. 5b squared over 2 minus 3b equals b over 4. Oh no, Chavez, now what? You're done. You're just doing algebra now. I think the best move, this is just me, I think the best move, I see a 2 and I see a 4, and I want to get rid of all the fractions. So I think the best move is to multiply everything by, you can by 2, but if I multiply by 4, I get rid of that 4 also. Does that make sense to you guys? We're just doing algebra. We're just doing algebra. So multiply everything by 4. How many times does 2 go into 4? 2 and 2 times 5? 10b squared minus 4 times 3. 12b equals b. I'm going to move that b to the left. 10b squared, if I move that to the left, minus b, it's going to be minus 13b equals 0. Are we still okay? I'm going to factor out a b. I'm just doing algebra, guys. So let's see what I have. 10b minus 13. So it looks like I have two answers. Only one of them is valid. So one b value can be 0, or the other b value can be, well, I guess if you don't see it, let me show you. 10b minus 13 equals 0. So b equals 13 over 10. Do you guys see that? Why can it not be b equals 0? Yeah, and you haven't moved. So it has to be 13 over 10, unless I made a mistake somewhere. Is there a 13 over 10 in there? So you can see how this question is almost entirely algebra. The only calculus is in the very beginning with the setup. You got to know that. And then the antiderivative part. Everything else is algebra. Are we cool, guys? So the calculus is not going to be what's going to stop you. It's going to be the algebra. Cool? Okay. Example 6, what do we have here? Obviously, you can tell, as soon as you see this format, where did I get this question from? Yeah, let's give them credit. Delta. I got this from Delta. The regions A, B, C, and D in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 4, so I'm going to put 4 right off the bat. That's just the area. Why don't they put a negative? Because the area is not negative. But if they were to tell you integral from -8 to -5, you would say -4. Are we in the clear, guys? The area in region B is 11, so I'm going to put 11. The area in region C is 19. And the area in region D is 13. What is the average value of f on the interval -5 to 7? Okay, I see average value of f. Immediately, I just go right into average of f equals 1 over b minus a, integral a to b of f of x dx. We're not robots. We verified where this came from. Average velocity, that's how we derived it. Are we still okay? All right, they want to know the average value from -5 to 7, so I'm going to fix it. 1 over 7 minus a -5, integral -5 to 7 of f of x dx. So let's see, 7, 8, 9, 10, 11, 12, 7, 8, 9, 10, 11, 12. So 1/12. And then I'm going to multiply by the area between -5 and 7. Where's -5? Right here. And 7 right here. So it's going to be 11 minus 19 plus 13. I don't know. Maybe you want to do 11 plus 13 and then 19. Subtract the 19. 13, 23, 24, 24, and then 20. So 4 plus 5. So is it 5 over 12? And I think that's it. Oh, that's positive because there's more above than below. 13, 23, 24, 24, and 20 is 4, but add one more, 5. Yeah, 5/12, guys. And that's it. How do we feel? Yeah. All right, let's see. One more, I think. And then we got a new lesson. So we're ambitious today. We're recovering from yesterday. Let f be the function defined by -2x squared minus 3. What is the average value of f on the interval -1 to 1? Okay, let's just do it. Let's just do it with our little formula here. So 1 over 1 minus a -1. You don't have to always do that, guys. If you know that the difference between -1 and 1 is 2, you can just do 1/2. Integral between -1 and 1 negative 2x squared minus 3. I already started it, so too bad. I was kind of tempted to go from 0 to 1, and whatever that is multiplied by 2, but I already did this. Do you guys see why I was tempted to do that? This function is an even function. So it looks something like, it looks something like this. Of course, it's skinnier, but it looks something like that. So I already know the answer is going to be negative because you're always below the x-axis. And then negative 1's like right here, 1's like right there. So I was kind of tempted to just do 0 to 1 because 0 is easy to do. And then multiply that by 2. Do you guys see that?
Yeah.
But do you guys not want me to do that? I won't if you guys don't want me to. No? Okay. All right, here we go. 1/2. Antiderivative of negative 2x squared is negative 2x cubed over 3 minus 3x. And I'm evaluating this between negative 1 and 1. And we're always going to do upper minus lower. So let's see, 1/2. Put my bracket again, upper. Negative 2, parenthesis 1 to the third power over 3 minus 3 times 1. That's upper there. Minus lower. Negative 2, parenthesis negative 1 to the third power over 3. Can I fit it? Minus 3 times negative 1. So let's see what we get. 1/2 bracket. That's negative 2/3 minus 3. We'll figure out that in a little bit. Minus, and I'm going to get a positive 2/3 plus 3. Let's see, does anything cancel? Nope, everything combines. So I'm going to have, here's my 1/2 bracket. I have a negative 2/3, and when I distribute that negative, that's going to be another negative 2/3. So that's a negative 4/3. Do you guys agree? And then I have a negative 3, and then when I distribute that negative, I have another negative 3. So that's going to be minus 6. Do you guys agree? All right. I can actually leave it like that, but let's do better and just write it as one number. If it were free response in the AP exam, I would leave it like that. No big deal. Let's see. 1/2 bracket negative 4/3 minus 6 times 3. What's that? 18. 18 over 3. So 18 and 4. That's 22. So I'm gonna, and then well, I guess I'll write it. Negative 22 over 3, but I see 2 goes into 22 11 times. So negative 11 over 3 is my final answer. I don't see any mistakes. I think we're okay. We are good though, right?
Yeah, I didn't know that.
It would have been cool. I used to know someone at UH. If you guys, Dr. Becky George is her name. If I would have given her a heads up like that you guys were going, she might have been able to give you guys like a personal tour on a math class or something. But because she's no longer there, now she's at Georgia Tech. Is that a big university? I don't know. Is that? Yeah, so she's at Georgia Tech now. Dr. Morgan he's kind of intimidating. So I know him. Like, I think he knows me by name, I think. But he's always so sarcastic that I'm kind of scared to talk to him. I'm like, Dr. Morgan. Like, he made fun of me last time because I was like, we were doing a series convergence. And he's like, this is how you write your convergence series? Like, yeah. Like, man, I can barely understand that handwriting. And I'm like, I couldn't tell if he was like demeaning me or he was like, and then he just tapped me like, and I guess at that moment when he taps your back, he's just messing with you, right? Like he's like letting you know. But to me, I was like, okay, I got to do better. Like I knew what I was doing. You know, when you're going fast, you just scribble. So he was just making fun of my how bad it was, I guess. All right, how do we calculate area between two curves? So you guys already know. You guys already know. So look, draw this. Draw this curve first. Call this curve in red F. And do you guys agree that area below the F curve from A to B is just integral A to B of f of x? Okay. And then I'm going to change my color if you have colored pencils. I'm going to draw this curve here. What's after F? G. I'm going to call that G. And I'm going to say that the area underneath G is a to b of g of x dx. Are we still okay? Okay, and I'm going to change my color again. I want this in green. How do I get that area in green? Yeah, you could, if you choose, you can do integral from a to b of f of x dx minus integral from a to b of g of x dx. If you choose, you can do that. Is there an easier way than doing two separate integrals? Can I do one integral? Are my limits the same? So can I just say integral from a to b of f of x minus g of x? Can I do that? Yes. Now be warned, don't get offended. Sometimes they put parentheses here, sometimes they don't. It is understood if you don't see parentheses, it does not mean dx times g of x. It is understood that it's all this times dx, because you still technically have like rectangles in here. There's still Raymond sums in there. Does that make sense to you guys? So we're still finding the height of that rectangle in black, and we're multiplying it by dx's. Cool? Is everyone okay? All right. The concept's straightforward. There's nothing crazy. Sometimes you need calculators, sometimes you don't. I think for these, let's go ahead and practice with our trig, secant squared and sine. Yeah, you don't need a calculator for this one. Ready? Help me out. I want that area in blue. Tell me what to write. Integral 0 to power 4, because those are my limits. Here's 0, here's power 4. What curve is on top? Secant squared x minus what curve is on bottom? Sine x. And I'd like to do it formal, so there it is in parentheses with my dx there. If the textbook does not put parentheses, relax. They did not do a typo. It's just understood in the math world that it's that minus that, and they're just being lazy and put the dx. Are we cool? All right, let's see. Can we do this by hand? Is there an antiderivative for secant squared? Yes, there is. What is it? Tan x. So I'm going to write tan x minus, what's the antiderivative of sine? Positive or negative? Negative. So this is going to turn into a, and because there's more than one term, I put both of them in little brackets. I put a 0 in the bottom. Power 4. You are done with calculus. The rest is just, can you evaluate it? Upper minus lower. What's up? Oh, these aren't polynomials. You only do that for polynomials. X squared plus 2x plus 5, those you do that. Plus 1 divided by that number. Are we okay, guys? Yeah, okay. Here it is. Upper, tan of power 4, unit circle doesn't go away, plus cosine of power 4. They're being kind of nice to us, I guess. Minus tan of 0 plus cosine of 0. Ooh, some of you guys, if you go too fast, you might mess up with cosine of 0. Yeah. What is tan of power 4? 1. What is cosine of power 4? Minus tan of 0? 0. And then cosine of 0 is 1. I see they're making the job easy for me. I can see that the 1s are going to cancel out because it's that when you distribute that negative, there's a negative 1. So my final answer is just ¿Cómo te sientes? How do you sit? ¿Cómo te sientes means, we already had this discussion, right? Yeah. All right. You're going to have to be good at algebra, especially for the non-calculator part where they give you something like this. You guys ready to tackle this question? So I want the area, as you can see, but they don't tell you anything. They just say find the area of the shaded region. That's all they tell you. So what do you got to do? You got to use your algebra skills. You got to find where they intersect. How do you find where they intersect? Well, you equal them to each other. Negative x equals 2 minus x squared. Do you guys remember that skill? And now, what am I going to do? I'm just going to move everything to the left. So I have x squared minus x minus 2 equals 0. Well, so because I wrote it like this, positive x squared. I did it on purpose because I like to have my x squared positive. And now, I'm just going to factor, guys. And this one's easy to factor. What two numbers, when you multiply, give you negative 2, but when you add, give you a negative 1. Negative 2 and 1. So that means that my intercepts are at x equals 2 and x equals negative 1. So put there for good notes that this value here is x equals negative 1, and this value here is x equals 2. Are we still okay? All right. Now what do I do? Integral from what to what? Negative 1 to 2. What curve is on top? 2 minus x squared. What curve is on the bottom? Negative x. Ooh, that's a good question. Thank you for saying that. So pause for a little bit. How do you determine which one's on top, which one's on the bottom? Just draw a vertical line. And then based off this vertical line in blue, which curve is on top? The parabola. Which curve is on bottom? The linear line. See?
So a line through the shade.
A line through the shaded part.
Oh, okay.
Draw a vertical line through the shaded region.
You drew the line. You could have done that over there.
If you do it to the left, the
It's still.
Yeah, you do it like.
Well, in the shaded region. In the shaded region, it's always, yeah. Yeah, make sure, because that's what we're finding, the area of the shaded region all the time. So when you draw your vertical line, for that shaded region, the parabola is always on top. And the linear line is always on bottom. Does that make sense? If they would have asked, like, because they sometimes do, like, I want the area from negative 2 all the way to 2. Well, then, yeah, the linear line's on top from negative 2 to negative 1, which actually that's probably what's next, what's coming up next. But yeah. And they do that to you a lot in the UH quiz. All right, we're done. Now we're just doing, well, we're almost done. Just one little bit of calculus here. I'm going to rewrite this, guys. So here we go. Integral, negative 1 to 2. That negative x squared, I'm going to put it first. Negative x squared. And then I'm going to put this plus x next. Plus x. And then plus 2, close it, dx. Is everyone okay with that expression? Okay. Now I'm going to do antiderivative. So my antiderivative of negative x squared is going to be negative x cubed over plus, what's antiderivative of x? Perfect. What's antiderivative of 2? 2x. I have several terms. Put that in brackets, negative 1 to 2. And now very carefully do upper minus lower. Put the equal sign and put giant parentheses. So let's see, negative 2 cubed, that's negative 8. Over 3 plus 2 squared is 4. 4 divided by 2 is 2. And then plus 2 times 2 is 4. Let me know if I make mistakes, because I make them all the time. That's for upper. Minus, let's see, negative 1 cubed is negative 1, but I already have a negative. So it turns to 1/3. And then negative 1 squared turns to a positive. So 1/2. And then 2 times negative 1, negative minus 2. There it is. I'm going to leave it like that, guys. Yeah, I'm going to leave it like that. Because you know what? Now I feel guilty. Let's go ahead and do it. Let's see. Don't worry. It won't take that long. Let's do it. Negative 8/3 minus 1/3. That's negative 9/3. Oh, it's going to come out pretty after all, guys. Negative 8/3 minus 1/3, that's negative 9/3, which is negative 3, right? And then 4 plus 2 is 6, plus another 2, 8. Yeah, I did this. 4 plus 2 is 6, plus another 2, when you distribute that negative. Oh, but I still haven't done the half there, right? Minus a half. All right, so let's see. 8 and 3, that's 5. 5 minus a half, so 4.5. So 4, 2, 8, 9. So 9 over 2. There, that's the perfect answer. How do we feel, guys? I would just box it. Usually when they just want area of shaded regions, you can just leave it. All right, next one, you need your calculator. You definitely need your calculator on this one. So let me take out my calculator so you guys can see it. How are we feeling? Can we keep going or no? Is this the last question?
Yeah.
Hey, we just did 2 lessons in one. In case you're feeling like, why is this lesson taking so long? That's because we did yesterday's lesson and today's lesson. Yesterday's lesson would have just been average. Let's just find the average. And then today's lesson would have been like area between 2 curves. But we did 2 things. Okay. I think you should be proud. Okay. You guys are like, whatever. All right, here we go. I have a curve. The curve is 2 cosine x, and I have another curve, x squared minus 1. Can you tell which one is which? That's where your algebra skills come in. Perfect. That's x squared minus 1. And then the top one is 2 cosine x. Cool? I want to know where they intersect. So the first thing you're going to do, you're going to go, sorry about that, guys. You're going to go 2 cosine x equals x squared minus 1. You have x squared minus 1 equals 2 cosine x. You're not going to get a perfect number. It's going to be a decimal that probably goes on forever. Use your calculator. You guys ready? So on y1, remember where you're putting your equations. On y1, I'm going to type in 2 cosine x. So go to y equals, I'm going to clear mine, 2 cosine x. On y2, I'm going to type in the other one. What was it? X squared minus 1? Yeah. And then I'm going to click on, you know what? I want to use the exact window they use. -3 to 3 and -2. These are x values here. And these are y values. So you guys tell me those. So let's see. Window, -3 to 3. And what did they use for y values? -2 to 3. Oh, you're all good. It's good. And I'm going to push graph. Yeah, it looks exactly like theirs. How do I tell? Now it's symmetric. I can tell that it's symmetric on the y-axis. How do I tell the calculator to find this intersection? Trace. So second, the trace button, which is calculate. And then which one of them is it? Intersect, number 5. And then first curve, yes. Second curve, yes. It says guess. There's 2 of them, so go to whichever one you want. I'm going to go to the left one here. Enter. And there it is, -1.265424. So, and I'm going to store that. Guess what letter I'm going to use? A. So there it is. If you push X, it comes out. And then just push store, alpha A. What do you think B is? What do you think the other intersection is? Is it the same value but positive? Yeah. Second, calculate. Number 5. Enter, enter. Guess, scroll all the way to the right. Come on, buddy. Come on, run, Fido. Here we go. Enter. Intersection 1.2654. It's the same, but positive. So, second, quit. X, enter. And I'm going to store it to letter B. I mean, I don't have to. I could just go opposite of A for the next one, but I want to show 2 different letters. And on the exam or anything, I'm going to put, let's see, I'm going to say that value is x equals -1 point. What was it again, guys? Give me more digits. And I'm going to put an arrow, and I'm going to put A. And then for the other one, I'm going to do the same thing. X equals 1.265423706. Store it to B. And then when I do my integral, I'll do it in a neutral color. Integral What's my lower limit? A. What's my upper limit? B. That's the right way to do it. Because you told them already what A is, and you told them already what B is. Don't write A or B unless you have somewhere in your paper what A and B is. You know what I mean, guys? All right. Which one's on top? Yeah, perfect. 2 cosine x. Which one's in the bottom? X squared minus 1. Make sure if you're going to put it in parentheses and not distribute the negative, make sure you do that. And make sure you put your dx, because without the dx, you really don't have something to sum. You're just adding up a whole bunch of heights. Are we okay so far, guys? All right, there it is. We're just going to type it in the calculator. Let's be smart. Do you have to type? So I'm going to push math, number 9, and I'm going to push alpha A here, and I'm going to push alpha B here. Do I have to type the expressions again if I already have them saved in Y? No, just know which one is which. I already forgot what I put on this. Which one's it? What? Y1? Okay. Alpha trace Y1 minus alpha trace Y2. And then go to the right and push X in there. And then push enter. And there it is. Because you didn't round, because you used the perfect from the intersections, 4.994 is your answer. You can put more digits, but never less than 3. And I'm telling you guys, it happens all the time. A kid just writes 4.99, and we don't give them the point. It sucks, but 4.994 or 4.995. 4.994. I already forgot the last digits. 90778. 90778. You can round it or you can truncate it. Does not matter. So 4.994 or 4.995. How do we feel? We feel pretty good? All right, guys. Let me put some stuff on Delta for you guys so you guys can practice. And then tomorrow with our short class, we'll do some stuff on paper. Cool? What's up?
Tomorrow is the